good afternoon to everybody. The agenda for today's webinar is displayed on the screen. Hopefully all of you can see it. We first start with the design of a high-pressure hose, including its components, material, and then go through the materials usually used in thermoplastic hoses. We go through the hose manufacturing and look through the typical process of this. We go through the assembly manufacturing. We will differentiate between hose manufacturing and assembly manufacturing, marking and testing, and go through the quality assurance, talk about authorized assembly centers and pressure testing of hoses and hose assemblies. This presentation have been jointly prepared by Parker and SPIR STAR, and Christopher Schmitt from SPIR STAR will also take over part of the presentation, starting with making of hose assemblies. Our next slide shows the general design of a thermoplastic hose. Every hose consists of three basic components, and that's the core tube, or sometimes this part is also referred as liner. Then we go to pressure reinforcement and thermoplastic sheath or cover. The very outside component, which you can see on the photo, is just a metal sleeve crimped on the sample to make it look nice. So, three basic components. Two of those basic components are made of thermoplastic material, and that's core tube and cover. Of course, there's not only one alternative. You often find rubber hose used in water jetting applications, but we will talk about it later and see why thermoplastic hose is a preferred one in our industry. Thermoplastic, all nice words. What is that? That's a polymer which becomes pliable or moldable above a specific temperature and returns to a solid state upon cooling. This process is reversible. So if you heat thermoplastic material again, it will again becomes softer and will flow again. That is the nice thing of the material, and this allows it to be processed to manufacture the thermoplastic hose. A few words about comparison. General comparison of thermoplastic materials and rubber. Of course, it's not always possible to put all thermoplastic materials, let's say, in one bucket and refer them as a standard thermoplastic. Of course, that's not the case, but the materials which are typically used in thermoplastic hose manufacturing have quite a lot of similar properties. And most of that properties are superior compared to rubber ones. And the first one is abrasion. If you compare the abrasion properties of rubber and thermoplastic hose, you will often see that thermoplastic offers a superior cut resistance, superior abrasion resistance, and therefore extended service life of the hose, which is obviously the important parameter for a user. By far greater ultraviolet, ozone, and seawater resistance. For exposed installations, especially in the UV environments, like under sun, direct sun exposure, in the tropical and hot areas, if the hoses are used somewhere on the construction areas where they exposed to environmental influences, that's the very positive property of thermoplastic material above the rubber hose. Also, in this case, that's not just the properties of the materials, they all result in a better hose life. Weight savings. Just out of ergonomical aspects, it's important for an operator to operate an easy, flexible, and light hose. Also, some energy savings. Let's talk a little bit more about different material types which are used in the hose manufacturing. And there's a list of a few representative materials. Not all of them are equally relevant in our industry, but all of them are important for thermoplastic hose. Polyamide, polyester elastomer, polyurethane. In fact, the correct description would be rather thermoplastic polyurethane, polyoxymethylene, and different fluoropolymers. Let's start with polyamide, also known as nylon, which is just a market name, used in 1930s by the plastics manufacturer DuPont, which is one of the most important materials for making hose. There are different grades of it used for different hose types, and this material is really very widely used. It offers smooth surface. Hydrolysis resistance means the material does not absorb water, which is in fact not quite correct. Different grades of polyamide do absorb water in more or less quantities, but in general they are very good hydrolysis resistance. Very good chemical resistance, which is not necessarily relevant in water jetting industry, but if the hose has to be used with paints, oils, or solvents, which is very often the case in hydraulics or oil and gas industry, this material offers very good chemical resistance. Also low permeability for gases. Polyester elastomer is less relevant. There are also two examples of market names, Hytrel and Arnital, made by different companies. It's rather used in the lower pressure hoses. Standard hydraulic hoses are utilizing this material quite often, mostly because of low temperature resistance and also very good flexibility and also rather low prices, material price. Polyurethane or thermoplastic polyurethane is rather correct description of this material. Is mostly used for the hose covers, and it offers very high flexibility and great abrasion resistance. On the delivery hoses, let's say 3/8, half-inch, 15 to 20,000 psi hoses. It's the absolutely material of choice. On the twin hoses used in hydraulic applications, there's also the material of choice because of easy weldability. Then we go to the probably most important material in our industry and in our applications. That's POM, polyoxymethylene. The ring listed here is just one of the very well-known market names, also from DuPont. This material is used in the high pressure hoses. Start with tube cleaning, 1,000 bar, 15,000 psi and above, and all highest pressure hoses above, let's say 2,000 bar, 30,000 psi are utilizing only polyoxymethylene. And the reason for that is that the mechanical properties of this material are so high that it is in fact the only alternative for this very high pressure. However, it's also a relatively brittle material. It's kink sensitive, so it's also not very easy to process, but the high mechanical properties give the advantages to use this material in high pressure and especially highest pressure applications. The next slide is referring to various fluoropolymers like PTFE, also known as Teflon, and believe it or not, it's also market name from DuPont, which also invented this material in 1940s, I guess. Very well known in various applications with extremely high chemical resistance, which is resistant, in fact, to nearly all chemicals. It's probably easier to list chemicals where the material is not resistant to than vice versa. And that's, however, not the material used for high pressure hoses, because the mechanical properties are relatively low. The great advantages are fantastic chemical resistance and also very high temperature resistance of this material. Let's go over to the pressure reinforcement. There are basically two types of pressure reinforcement used in high pressure hoses. It's either yarns or fibers or steel wire. Yarns can be basically of two types. There are in fact much more, but the two ones, polyester and aramid, are the most often used ones, and the aramid, wires are in fact used for the highest pressure hoses. Talking about yarns, they are obviously lighter compared to wires. They give the hose good flexing properties, not a bad kink resistance, but the volumetric of those hoses is normally higher, as the yarns have a high elongation compared to wires. They have some disadvantage, like ultraviolet light sensitivity, but it's again only partly important, as obviously yarn is not directly exposed to the sunlight or something like that. This one, by the way, is referring to aramid wires with the statement 5 times higher tensile strength compared to steel wire. Well, that's only partly correct. It's comparable, in fact, but due to high cost and relatively difficult processing, that's normally not used in very high pressure hoses. Seawater resistance is certainly nice for hoses used offshore, or even subsea, but it's not necessarily relevant for our parts. Steel wire is brass plated for corrosion protection. Obviously, fantastic mechanical properties, high pressure capabilities, and again, if you start talking 15,000 psi and above, normally all hoses are steel wire reinforced. How you can apply steel wire on the hose? There are basically two processes: braiding or spiraling. I was a little bit ahead, sorry for that. General manufacturing process of high pressure hose includes inner core extrusion, and that's basically making a very long plastic tube. Then the pressure reinforcement is applied either by braiding or spiraling. Then the outer cover is extruded over the so-called semi-finished product, and then the basic manufacturing is completed. Then the final control of the hose is done, and after this process is completed, the hose assembly manufacturing can start. Inner core extrusion. What you see here on the slide is the piece of equipment which is called extruder, which is used to extrude. And now you will see a video of the extrusion process. What you see here is the material which is injected into a screw. The screw is rotating. The screw is also heated. So the material is melted, pushed through a die and a mandrel, forming a tube, and then it enters the cooling chamber where the shape of the tube is fixed. Braiding and spiraling. Another video. Anita, can you please start one?
Give me a minute.
Very good. It's loading, and what you see here is the braiding process. In fact, it's waving the strings of wires over the hose. Looks quite complicated, but the advantage of the process is that the machines are quite standard, so you can buy the braiders from the shelf. What you see here is that the individual wire strings are woven between each other. So there are always some spaces, some gaps between those individual wire strings. That results in general in a low pressure capacity of the braided hose. On the contrary, the spiraled hose, and now you will see the video of spiraling, does not have this disadvantage. As you see, there are many bobbins with wire on each bobbin. The core tube is moving and the wires are spirally laid on the hose, very close to each other with almost no gaps, and that results in a great pressure capability of spiraled hose because there's generally no gaps between wires. Of course, that not only one layer of spiraled wires over the hose, there's always an even number of spiral layers which are made in cross directions. So one is spiraled clockwise and the second one is spiraled anti-clockwise. And they are either 2, 4, 6, or even 8 spiral layers. Also on this slide, you can see the difference between these two processes, braiding and spiraling. Also here, a cross-section where the gaps between wire strings are visible on the braided hose. Outer cover extrusion is in principle not very different to the core tube extrusion. Also here, the material is melted in the extruder and it's put over the spiraled or braided hose, forming a nice round shape. And after it's put on the hose, the material is cooled, so the hose retains its shape. That should be all about the hose manufacturing, and I will now hand over to Christopher Schmitt from SPIR STAR, who will continue with the manufacturing of hose assemblies.
Thank you, Jose. Thank you, Maxim, for your presentation. A warm welcome also from my side. My name is Christopher Schmitt. I have been working at SPIR STAR for 15 years now. I'm responsible for the technical department as technical director. Today, my part of this presentation will be the hose assembly process. We will start with the assembly process in detail and proceed with the special marking requirements of high pressure hoses. The second topic is the quality. This topic explains how quality of a high pressure hose is ensured. The first important point is a hose must be assembled only at an authorized assembly center which fully meets the requirements of the manufacturer. A final pressure test is essential. Jose or Maxim has explained the bulk hose manufacturing in the previous slides. That a hose gets usable for a high pressure application, it needs to be assembled by the manufacturer's written instructions. Following points need to be considered. The right fitting selection should be taken, that the right fitting for the right hose is selected, the right cutting with the right equipment, a proper sleeve assembling according to the instructions, a careful insert assembly with the right machinery, crimping with the correct equipment and the hose parameters. Finally, the marking of the hose should be according local and international standards. The crimp zone of the hose assembly is a sensitive zone which affects the quality and lifetime. Well-known standards like the ISO 4413 and the German Statutory Accident Insurance Rule, DGUV 113, state that a new hose assembly must be made from hoses which have not previously been in service as part of another hose assembly. Also, mix and match is prohibited. This in detail explained. It's not allowed to use different manufacturers of hose and fitting. As mentioned in the previous slide, it's only allowed to use original fittings of the hose manufacturer. Only certified partners are allowed to assemble high-pressure hose of one manufacturer. Otherwise, the hose assembly will or can cause considerable damage. Also, injuries to the human body cannot be ruled out. The first step is always a proper cut of the hose. A special hose saw is needed. A standard hydraulic hose saw is not applicable. So this was also mentioned by Jose already. Always keep in mind hydraulic hose, rubber hydraulic hose is not a thermoplastic high pressure hose. The hose cut according the required is always done according the required length of the customer. The length of the hose assembly is always defined from face to face. The top picture shows a hose assembly with 2 high pressure inserts with the cone and thread, and it shows that the total length is always important for our assembly. This fact needs to be considered if you order a hose. All assemblies are assembled based on a standard. It's a German one. It's a DIN 20066. You can see the measurements in the table. If different length tolerances are required, this needs to be discussed with the hose assembly manufacturer. It's possible, but it has to be taken into special account. Before starting the crimp procedure, following points are necessary to check according the manufacturer's written instructions. Original and matching fittings need to be used. The fitting assembly is done probably, so you have to check if everything is still in place. The right die set is selected according to the instruction and installed in the calibrated and already adjusted crimper. During the crimping steps, you always have to take care of the right positioning of your fitting inside the die set. After crimping, the insert collapse is checked by a pin gauge. Also, the outer cover of the crimp sleeve has to be checked if it's within the tolerance written in the instructions. These steps will be shown in detail by the following slides. This slide shows special equipment crimpers used for high pressure hoses. These crimpers are available for the assembly centers through the hose manufacturers. No standard hydraulic hose crimper is able to crimp a high pressure hose according the manufacturer requirements. Only these crimpers are proper and safe high pressure hose could be manufactured. After crimping, the hose, as already mentioned, will be checked by the insert collapse. Usually you use a no-go and the go gauge. These gauges are shown on the left side of your screen. The no-go gauge should be stopped in the middle of the fitting of the hose tail. The go gauge should go through the whole fitting and should not stop somewhere. If the no-go gauge should stop in a different area or should go through the complete fitting, it's not crimped correct. If the go gauge will stop somewhere, it's also not crimped correctly. Both cases lead to an unusable hose assembly. The following video will show the practical implementation of the crimping process. Yeah, thank you very much. So you saw only the no-go pin gauge. There will be a second step checking the go pin gauge. That the customer gets an idea of the parameters of the hose assembly, it's essential that the sleeve will be marked permanent, readable, and according the national or international regulations. At least the hose assembly should be marked with the working pressure, because sometimes the working pressure is reduced by a pressure rating of the fitting. The hose assembly manufacturer should be written on it, a logo or the name, just to be sure who has done the assembly. And the assembly date should be marked on the fitting. This could be seen on the picture in the middle, you see the month and the year of the assembly. This is important if you consider the use period or the recertification process. Further information could be added on the sleeve, like the standard number. There are a few hose assembly or hose assembly standards, and some hoses are added with the serial number, where you get the fully traceability to every single part used in that hose assembly. Always consider that the national regulations may require further or different marking requirements. So this part of the presentation will explain how the quality of a high-pressure hose assembly is ensured. Only authorized assembly centers are allowed and equipped with the right equipment. Also, they have the trained personnel in place and could guarantee a quality high-pressure hose assembly. Based on these points, the assembly center will be audited on a regular basis and a valid certificate will be created. For your information, all assembly centers should be able to show you a valid certificate at any time. The assembly centers are also equipped with a high-pressure test unit. This test unit is used to perform the final pressure test of each hose assembly. This test is performed according to the manufacturer's instructions, national regulations, or customer requests. A common test method is the test according to the ISO standard 1402. The required test pressure factors are committed in different international standards. For example, a very general one, the ISO 7751. Also, a common standard in Europe for high pressure hoses is the EN 1829-2. This standard refers also to the ISO 1402 and a test factor 1.5 to the working pressure. This is also stated in the ISO 7751. The European standard 1829-2 also allows to reduce the test factor if the hose has a working pressure higher than 3000 bar. So you can, in this case, it's allowed to use a test pressure factor of 1.2 multiplied to the working pressure. This graph shows a typical pressure curve of the ISO 1402. So you see also that the working pressure of this sample of the hose was 2500 bar. This results to 3750 bar with a test pressure factor of 1.5. So this test pressure of 3750 bar should be reached within 30 and 60 seconds and should be held for a period of time 30 to 60 seconds. And during this holding time, there should be no unusual pressure drop or any signs of leakage. So if there was no unusual pressure drop or any sign of leakage, the hose is ready for use and will be packed and sent it to the customer. Thank you very much for your attention.